What determines the lowest frequency that a microphone can pick up? I want to preface this by saying I am not an audio engineer. I do not have a physics degree. I do not understand the ins and outs and intricacies of capsule design or microphone body design or material sciences. I am a dope. What I believe the answer is the capsule. Not the diaphragm, necessarily, or on its own, but the capsule. I initially thought, okay, the diaphragm size is going to contribute to that, because the bigger the diaphragm, maybe the more low end it picks up. But then I started looking around, and small diaphragm condensers really have zero issue picking up frequencies down to 20 hertz. And then I went to Earthworks, because they are one of the leading brands in terms of SDCs, and I looked at their, let me see what the model number was. It is the QTC50. It is their higher end measurement microphone. I would say the capsule is probably 7 millimeters, maybe 5 millimeters. The frequency response, 3 hertz up to 50 kilohertz. So clearly, small diaphragms do not eliminate a microphone's ability to pick up low frequencies. So what I believe it would be is all the other components surrounding the microphone diaphragm, the capsule, the backplate, the resonance chamber, all of that. Also, the electronics within the microphone are going to contribute to that as well. That's where you'll get the kind of tuning of the microphone. Because certain capsules, the CK12, the 47, all of those famous Neumann, German, Austrian capsules have certain resonances, and a lot of the electronics in those microphones offsets that. They use the electronics to remove certain resonant frequencies that are inherent in those capsules. So I'm sorry I don't have an exact answer for you. I am going to say the entire microphone plays a part in how wide of a frequency response it picks up. But then you ask about the MTP350CM. Why does this microphone have such a high frequency roll-off? You said around 90 hertz. Let me switch to it. Now I am on the MTP350CM, gain at 3 o'clock on the 18i20. You should hear a lot more treble and air on this, especially compared to the SM7B. That's the Lewitt sound. But as Fred pointed out, you should also hear a pretty aggressive built-in and permanent high-pass filter around 90 hertz. The reason that I believe they did that is because this is a handheld stage microphone, and what do most singers do when they are on stage? They put their mouth right on top of the grill, and this engages the proximity effect to the fullest. So that high-pass filter should be offsetting a lot of that proximity effect, at least in the bass frequencies, which would ultimately be rolled off anyway. And then you have that highly exaggerated top end, which should offset that proximity effect as well. Now, as far as how they accomplished that built-in high-pass filter, I can't say. Perhaps they have some kind of electronics that roll off starting around 90 hertz. Maybe they designed the capsule to have some kind of resonance which causes a phase cancellation below 90 hertz. I have no idea because that is above my pay grade. I am a dope. I can't even do basic physics. So that is my answer. That is my demonstration.